Guys, welcome back yet again. Today we're going to look again at solving equations. This time we're going to look at two-step equations. Again, we're adding in the decimals. So again, remember, we're going to have to remember our rules for integers. We're going to have to remember our rules for solving two-step equations and our rules for decimals as well. So we've got a lot of things we're piling up. And again, I'll remind you, go back and rewatch any of the videos that you need to help you get the idea for this one. So you can go back and you can rewatch any of the old ones to help you, or you can rewatch this one again as well. I know you're getting really tired of seeing the same slide over and over, the same board here, but I want you to remember when we're solving equations, we need to keep it balanced and we need to isolate our variable. The one thing you'll remember that I told you about undoing multi-step equations, we have to undo following the inverse order of operation, or the opposite way. So remember, we're going to undo in the opposite order that we would do the operations. We want to undo them. So starting here, I take a look at my variable. I'm multiplying and I'm adding. Well, I want the inverse order of operations, which means the first thing I need to undo is my addition. I'm going to undo that using the inverse operation, which is subtraction. So we'll start out by subtracting 14 from both sides. On this side, I'm left with my multiplication, 0.5 times t. When I do the subtraction here, you'll notice I lined up my decimals. There's that implied decimal there. And I wind up with 5.5. So now I have it down to one step. I did my first step. There's still one step left. I need to get the variable by itself. I'm multiplying. How am I going to undo the multiplication? By dividing. Since I divided one side by 0.5, I need to multiply the other side by 0.5 as well. 5.5 divided by 5 gives me 11. And again, you can do that on scrap paper. I did it, the mental math, but feel free to write it down if you need to. I'm not always going to show you all the work. Sometimes I do it in my head. All right. So we solved that, and again, remember, especially in two-step equations, I want you to go back and check it. Pull out the handy-dandy calculator so we can check it. If I take 0.5, I multiply by 11, and then I add 14, I get 19.5, so it checks out. These ones you especially want to check to make sure that you did all your steps properly. So if you look over at this one, I'm multiplying and I'm subtracting. Inverse order of operations to undo it. The first thing I want to undo is the subtraction. So let's add 17 to both sides. All right. When I add 17 to both sides, I wind up with 0.8x is equal to 33.6. Now, how am I going to isolate the variable? Well, I need to undo my multiplication now. I'm going to undo that by division. And I'm going to use the calculator for the sake of time. This division one, when I divide 33.6 by 0.8, sorry, that decimal was a little high, I wind up with 4.2. And again, we can go back and check that. 0.8 times 4.2 minus 17. And I must have done something wrong somewhere, because that does not check when I try to put it in my calculator. 33.6 divided by... it gives me 42. I hit a decimal in an incorrect place somewhere. And this is why we check. I checked it and I had a decimal in the wrong place somewhere in my calculation. So let's try it with 42. 42 times 0.8 minus 17 gives me 16.6. Now it checks out. This is the importance of going back and checking our work. I can know if I'm right or wrong. I knew my answer was wrong. I fixed it. Okay, here you'll notice we're dividing and we're adding. So we want to undo that in the opposite order. So I'm going to undo my addition first using my inverse operation, which is subtraction. These ones cancel out. I'm left with that divided by 6.4. When I subtract 4.3 from 26, I wind up with 21.7. How am I going to undo this side now? I'm dividing. I'm going to undo it using multiplication. I'm going to set this up this way so that I can do my multiplication. I wind up up with n is equal to 138.88. I'm going to check my work since I did that multiplication rather quickly and in my head to make sure I have it right. So if I take this number and I plug it in, I get 138.88 divided by 6.4 plus 4.3 gives me 26. It checked out. My math was correct. I did it right. All right, over here you'll notice we're dividing and we're subtracting, so we're going to undo that in the opposite order. Let's undo my subtraction first using its inverse operation. Here you'll notice I'm now adding a positive and a negative number, which means I'm going to subtract their absolute values. I'm just going to come over here to the side, subtract the smaller from the larger. I wind up with 0.5. My larger value was positive, so I wind up with a positive 0.5, or 1/2. On this side, I'm left with z divided by 3.6. So I did my one step, now I'm going to do my second step. I'm going to undo my division. I'm going to undo that by multiplying. Multiply both sides by 3.6. I wind up with z is equal to 18. Now again, I'll plug that in and I'll check it. 18 divided by 3.6 minus 0.65 gives me the same number. So again, I'm going to go back. I probably misadded somewhere along the way. 0.5, that is correct. That's 30. Oh, you know what it was? I misplaced my decimal. I was not paying attention to where my decimal went. I should have 1.8, not 18. Now if we try it with 1.8, let's see if we get the right answer. 1.8 divided by 3.6 minus 0.65 gives me negative 0.15. All right, and again, 2 examples there of why it's so important to go back and check your work. We don't want to make silly mistakes. Both of those were simply me placing a decimal in the wrong spot. If you have questions, you know where to post them.